Alrighty guys, so this notes page is actually in Google Classroom and it's called I hope my pen doesn't die on me, just relations notes. Once again, it's a Google slide in Google Classroom and it's under videos and notes. Okay, and today's date is the 19th. Anywho, so the first thing first is a little bit of a review, starting with the definition of a coordinate plane. Now on your end of the notes you need to copy this down, which is a plane divided into four regions for graphing. I mean, it's just your standard graph that you're used to, that you've been using for a while, aka this guy right here. Okay, and then we have to label the parts of the plane. So it says label the origin, quadrants, x-axis, and y-axis. Now on your notes, there's a spot right here for the x-axis and right here for the y-axis. And then there's 4 boxes for each quadrant. Remember, top right is quadrant 1. And then it goes counterclockwise around. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now the very center of the graph, there's also a box. This is your origin. The origin, that point in the very middle. And its coordinates are 0, 0. X value is 0, y value is 0. It's in the very center. So that's just some review and some basics there of some vocab. And here's some more. So next up for our vocab, we have ordered pair. Now you also will hear this be called a point, right? A point, x comma y on a graph. An ordered pair is where we actually get our coordinates for the graph, for the points on a graph. And that's exactly what it's asking us to do in this problem right here. Gives us all these different points that have been labeled A, B, C, D, E, F. And we have to do is actually write them as ordered pairs. So, now they're all filled out for you. But what you would have to do to get these is you have to start at the origin. The origin's your starting point. Remember, it's 0, 0. And if I go to the left on my x-axis, I'm going in the negative direction. So to get to A, which is right here, I'd have to go left 1, 2, 3, which is negative 3 in the x direction. And then I would have to go up, which is the positive y direction. So I would have to go 1, 2, 3, 4. And that's how it gives you the positive 4 for your y value. And then, of course, it's just in quadrant 2, like we saw up here. This quadrant is quadrant 2. You'd have to do the same thing for all the other points. B, you're going 1, 2 in the positive x direction now because it's to the right. And then we're going in the negative y direction. We're going down 1, 2, 3. So positive 2 for your x direction, negative 3 in the y direction. And it is in quadrant 4 down here. Now C is a little bit different because we don't move left or right at all. We just stay put, so we don't move at all for our x. So it's 0. It's in line with this. It's in line with the middle for the x direction. And then we go up 1, 2, positive 2 in the y direction, so we got positive 2. And it's not really in a quadrant, it's just on the y-axis, because this is the first quadrant, this is the second, it's directly in between, on the y-axis. Alright, and then D, E, somewhat similar to what we did before. And then F, now we go left 1, 2, 3, 4, 5, and we're already on F, so we don't have to go up or down at all. So negative 5 is our x coordinate, 0 is our y coordinate. Okay. In two definitions that are very important for this unit, And you'll see that there's a big difference when it comes to something called domain and range of these two graphs. So a discrete graph is just a graph of distinct points. So for example, this guy up here is a discrete graph. It just is a graph with a bunch of points on it. The points are not connected in any way. You almost can think of it as almost like a scatter plot, if you've heard that word before. That would be a discrete graph, just points thrown onto a graph in some order. Now a continuous graph is different. It has points, but all the points are connected by lines and curves. And really, when you have a line or a curve like that, there are infinite amount of points just connected to each other, infinitely close together, to where it just makes this smooth line or curve. So discrete graph, not connected. Continuous graph, they are connected, line or curve. And that affects the domain and range. Okay. Alright. So, moving on to the next page. You can hear my phone go off.